So today we're going to look at 4.4, which is on perimeter. Not so much angle measure. I think we're going to stick with the perimeter problems. But basically the idea is you're going to be given the perimeter of a shape. They're going to tell you something about it, enough information to be able to find the length and find the width in the case of a rectangle. Or in the case of a triangle, we are going to do one that's 3 sides. You'll be able to find the first side, second side, and third side. All right, so earlier in the year, we've done these kinds of problems, very similar. You guys remember when we did consecutive integers? Problems like Joe's age is twice Maria's age, things like that.
Together they are 42 years old.
Yeah.
Things like that.
So those are the kinds of things we're going to take a look at. All right, so we're going to focus on perimeter today. So what's perimeter? What about the outside, like the color of it? Yeah, the length, right, of all the sides added up. Okay, so if you were thinking about putting like a fence around your yard, it's how many feet of fencing would you need to go around your yard. It's not how much stuff fits inside your yard, right? It's around the edge. Okay, that's your perimeter. So it's the sum of all the sides added up. Okay, as we go through the word problems, okay, we're going to see some key words, maybe like less than, shorter than, more than, is, okay, things like that. Those are all important words. Times, so there's a word that means times. Okay, so let's just take a look.
Guys, you have this chart on your, this is not for you to fill it in, but you have this chart on your notes.
All right, so let's start off with more than. Okay, what operation, when you see more than, do you think of? Yeah, addition. Okay, addition. So if I said something like you did 2 more homeworks this week than last week, that would be plus 2. You did 2 more than last week. Okay, larger than. What operation do you think of when you think larger? Yeah, that's also addition. Larger than or longer than.
I'd say longer than 2.
Like if I said to you, this table is 6 inches longer than the desk. Longer means it's plus 6. If that's 10 inches, that's 16. It's 6 inches longer. Okay? That would still be addition. Now, what about less than?
Minus.
Right. Okay.
Subtraction.
If I said this table is 3 inches shorter than that one, that means if you knew that one, you minus 3. That's this one.
Does anybody remember when it says like less than or shorter than? We have more than or larger than. It doesn't matter how we set it up. We could do x plus 7. We could do 7 plus x. What about when we have less than? Like 3 is less than a number. How we set that up? We said 3 is less than a number.
3 minus 3 less than sign and then n.
Yeah, 3 minus. Careful. Remember, what was the special rule we said when we have less than?
Oh.
Remember, Victor?
You gotta put the n minus 3.
Exactly. Remember, whatever number you get that's less than, that needs to be the second part. Put your variable first, x, y, whatever, and then the number will be minus whatever number you give. Right? When it's less than, when it's shorter than, right? Follow that rule.
Okay, here's an example. Think about the answer to this with numbers. What's 2 less than 10? 8. Okay, 2 less than 10 is 8. How did you get 8? Did you do 2 minus 10 or 10 minus 2? 10 minus 2. Okay, so if you see something like that, you have to switch the order you subtract them in. Okay, that's a little tricky. Same thing with shorter than. If I said this is 2 feet shorter than 10 feet, 2 feet shorter than 10 feet means 10 feet minus 2 feet. It's 8 feet.
So when it's more than, when it's larger, it doesn't matter. You could do x plus 7, you could do 7 plus x. But the order matters when you're doing subtraction. You gotta put the number in the second part, less than whatever number you're given.
And how about times? Yeah, that's when you multiply.
So what if it said three times a number? How do we represent that? You don't have to put the little dot. What can you put? This 3x, 4 times the number, 4x, 5 times the number, 5x. You don't have to put the little dot there. We know from the stuff we've done this year, if there's a number with a variable next to it with no sign splitting it up, we know that's multiplication.
Hey, and I also added the word of.
Yeah.
So if you saw something like the width is 1/4 of the length, of means multiply. Okay. I think we said this too longer there, and I just added that.
Yeah.
Do you guys have any questions on those key phrases?
And again, guys, that stuff we've seen. I mean, the longer than, shorter than, that might be new because we're talking about shapes and measurement. So those phrases might be new, but everything else we covered when we did word problems. But that was a while ago. That was first quarter stuff.
All right, so for the first one, Mr. Roy is going to just kind of step through it, step by step, and show you how to do it, and then we'll do a few more together.
All right. So again, like Mr. Hay, like we said at the beginning, we're either doing perimeter of a rectangle, or we're doing perimeter of a triangle. One or the other. That's all. When we're doing the word problems this week, those are the only 2 things that we're gonna use. Why are we doing this? Number 1, it's gonna be on the midterm. Right? There'll be a problem on the midterm that deals with perimeter of a rectangle. Right? So this stuff, the stuff we did Tuesday and Monday, that stuff not going to be on the midterm. But the stuff we do today, all right, these word problems, especially on rectangles, there'll be one on the midterm. So first thing says, the length of a rectangle, you guys have this written on your thing. You have this example. The length of a rectangle is 2 centimeters less than 3 times the width. Find the measure of the length and width. All right, so step 1. We're going to break it down step by step. First, let's identify the 2 unknowns, the 2 things we have to find. All right? That involves no math whatsoever. You just got to identify the 2 things that you're trying to find. Right? And on a test, on homework, we'll actually have, maybe even the examples we do today, we'll have the 2 things you have to find already written there for you. But again, it's up to you to set up the problem. So, usually when we're doing rectangle problems, we're going to find 2 things. Right? We're going to have to find 2 things. When we're doing a triangle, which is the last one we'll do today, you're going to have to find 3 things. When we're doing a rectangle, what are the 2 unknowns we're going to have to find? What are the 2 things we're going to have to find for that rectangle?
Length.
Yeah, length is one. What else? Length and width. Doesn't matter what's written in the problem, you're always going to find length and width. Now the order that they're written in is going to change the next step. Right? But the first thing we want to do is identify the unknowns. And a lot of times that's going to be done for you. So in this problem, when I write it down, I want to list them, the 2 unknowns, in the order that they show up in the problem. All right? So under this step, we're going to go back to this problem so you have a step-by-step on how to do it. All right? So we're going to identify the unknowns. All right? Ryan, what's the first unknown that shows up in this problem?
2.
Huh? No? What are the 2 things we have to find? Length and width. Does length show up first? Is length the first thing mentioned? Newman says yes. The length, right? That's the first thing. When we list out our 2 unknowns, all right, we want to do them in the order they show up. Length showed up first. So all I'm going to do is length equals, and then obviously we know width is going to be second. So that's step 1. I'm going to identify my 2 unknowns. Next, we're going to give each unknown value. I put, why do you guys think, why do you think Mr. Hager and I put value kind of like in quotes? Anybody think they might know why? Are these length and width going to get a nice number like 25, 33, whatever? Are they going to get a nice number? What are those unknowns going to have? Variables, right? Okay, that goes to these little steps right here. The second unknown, all right? The second unknown is usually going to get a single variable, right? My suggestion would be, whatever thing you're trying to find, like whatever is mentioned second, like width, use the first letter of that word. So W. If you're trying, if length is the second unknown, use L. All right? And then we're going to base the first unknown off of that variable. So whatever L is, we're going to use L again in our to set up our value for length. So again, we got to use those values. Again, same order, length, width. Width is the second thing mentioned. Well, the last thing in the problem, right? So what does that mean? What can I put for width? W, right. All right, width will be W. Now, we got to go back up. We got to figure out anything we do for length is going to be based off this W. All right? So the length of a rectangle is 2 centimeters less than. That's the first thing I see there. 2 centimeters less than. What do I do? What do I do when I have a less than? Who can tell me? Subtract. So I know, like Zach just said, I'm going to use subtraction. I'm going to use minus. And I'm going to leave myself a little space. All right? I'm going to leave myself a little space. After this minus, what am I going to put? Huh? Nope. Less than 2. So minus what, Rosie? Minus 2. Remember, it's a less than. It's got to be the second part. So it's minus whatever number is given. So it's minus 2. Now let's go back up. We covered this part, the 2 centimeters less than 3 times the width. What's 3 times the width? How do I represent 3 times the width? 3W, right? I'm going to put that as the first part. Remember, it's a less than. Less than, all right, goes second. So 3W minus 2. Okay? Now, this is where it can get a little bit tricky. Because before when we solved, we could just set these up, we could subtract them, we could add them and equal to whatever thing was given the problem. For this, I'm using a formula. All right? I'm going to use a formula. So I got to plug in these unknowns, length and width, into this formula. All right? So we're going to plug the unknowns into the formula, then we'll solve. If I'm doing a rectangle, it's going to be 2L plus 2W equals the perimeter. Right? 2L plus 2W equals the perimeter. In your book, it might have the P equals first, but I think the way you guys usually solve things, the equal sign is usually at the end. So I just want to make it go along with the way you've answered stuff all year. Triangle, 3 sides. We're going to do side 1 plus side 2 plus side 3 will give me the perimeter. Right? Mr. Hager made it a little bit bigger for you guys. All right? So rectangle, twice the length plus twice the width equals P. Triangle, side 1 plus side 2 plus side 3 will give you the perimeter. Now remember, we don't have nice number values for this stuff yet. We're just going to plug it in based on what we know. And it might help you guys if you want to put parentheses around the L and parentheses around the W. All right, so for this problem, what formula am I going to use? Rectangle or triangle? What kind of shape am I solving for? Rectangle, right? So I'm going to start with 2 because 2 is part of the formula. 2. Right now, what's my when I set up my values up here, my length and width. Right now, what's my length?
2. Wait a minute.
What's my length? Exactly. That's what I'm plugging in for length. All I know about length right now is it's 3w minus 2. I'm going to plug in what I know for length into this formula. 3w minus 2. All right? Back to the formula. Plus part of the formula. I have to put it there. 2, part of the formula. I have to put it there. Right now, what do I have for width?
W.
There's w. Just w. Equals, what's the P stand for? So Mr. Hager doesn't have to scroll back up. Can somebody tell me what the perimeter is of that rectangle? I didn't put a perimeter on it, did I? You have it up top, Mr. Hager? Oh, man. Didn't put a perimeter on there, Mr. Hager. Back. All right, so we know the perimeter, like Mr. Hager just added in, and we know our perimeter is 44. All right, so we'll go back down. So this whole thing's going to equal what? 44. Now, I have parentheses in there. With those parentheses, what am I going to have to do? What's it called? Distributive property. All right? What's distributive property mean? What math operation? Multiplication, right? So what am when I apply the distributive property to this first part, what am I going to get? 6w. What's the rest? 6w? 6w minus 4. All Corey did was just multiplied those two things. And then when I do this, when I do 2 times 2w, what do I get? I mean 2 times w, I'm sorry. Logan? Huh? Yeah, fill in your agenda. All right, we're just going to get 2w. 2 times w, because this is 1w. 2 times 1 is 2. And I just apply the w. Equals 44. Now, at this point, what can I do? Rose?
Plug in the number for the variable?
Not yet. I what Corey said. Combine like terms, right? I'm going to CLT. What are my like terms? Corey. 6W and 2W. They're both positive. What do you get? 8W. All right? Here's a like term. Here's a like term. 8W minus 4 equals 44. Kevin, now what? Good man. You do add 4. Add 4. Add 4. 8W equals what, Kevin? Good man. Last step. Maria? Divide by 8. 8. 8. W equals? Yeah, 6. Good. Now, yeah. So W equals 6. Now, once we get that, we're gonna plug in that number up top to the variable we just solved for. We just solved for W. All right. So now we're gonna have to go back and use our unknowns. All right. Let's put it this way. What part of the triangle did I just solve for? I just solved for the width, right? Because W is width. If I scroll back up, I just solved for width. All right? the width equals 6 centimeters. It equals 6 centimeters because I just solved for W. Width was the single variable. That's the easy part. When you do all that work and plug in the formula, you're going to get one of your measurements. You're going to get whatever that single variable was. Now I got to figure out my length. And the step said, number 4, plug in that variable, all right, wherever it shows up. So I got to figure out length now. How would I figure out length? What do you think, Jay? What do you think? How would I figure out width? I'm going to go back and use the value I set up for my length. And I just solved for W.
3.
Yep.
In parentheses 6.
Yep.
Minus 2.
Excellent. All right? So 3 times 6? What's 3 times 6, guys? 18. All right? 18 minus 2 is what? 16. 16. And what unit of measurement am I using? Centimeters. Good. All right? So there's my length, 16 centimeters. There's my width, 6 centimeters. The width, whatever the single variable is, whether it's length, whether it's width, that's the easy part because you already got it. The only thing is, that next part is you got to take that letter and plug it back in. All right, plug it into whatever you have up here to solve. All right, so similar to stuff we've done before, but the tricky thing is you got to plug whatever values you come up with for length and width, you have to plug them into that formula. All right, the 2L plus 2W equals the perimeter. Okay?
All right, so next one, very similar type, still a model rectangle. Okay, and this time it says we're going to draw rectangular shapes where the width is 1/4 of the length. Okay, so first thing we do is write down our 2 unknowns. Okay, next thing we have to decide is which one gets the single variable. Is it going to be width or length? Okay, how come? Length? You think length? How come? Yeah, because it's last. You always go with the one at the end of the sentence. Okay, so whatever appears there, that's your single variable. What's a good letter for length? L. Just make sure it doesn't look like a 1.
Guys, that example's on the back side of your notes.
Right, and now it says the width is 1/4 of the length. Okay. How are we going to write that one? How would you write 1/4 of length? Yeah? Yeah. 1/4 of means multiply and L. Okay, so there's our first step. Okay, just setting up width and length are expressions. Okay. Any question on step 1? All right, next step, I need the formula that has to do with the perimeter. Okay, I have a rectangle. Can somebody remind me what that formula is again? P equals, oh, yep, Sabrina? 2L plus 2W. Okay, and Ryan, what am I going to do with the 2 expressions I found and that formula? So how do we use these 2 things and this formula to help us figure out? And we're going to use the perimeter is 130. We'll come back to that too. Rose, can you help him out? One word. We're going to do it for the P, we're going to do it for the L, and we're going to do it for the W.
Oh, the width.
What do we do?
What do you do with those values that you set up?
We've got this, this, and that.
Yeah, plus them into an equation.
Yeah, we're going to plug them in. We're going to plug them all in. So this is my perimeter. Okay, so we're going to put that in for P. We're going to put that in for L. And we're going to put that in for W. Okay, so change all three of these things to the three things we have up above. All right, so Victor, what am I plugging in for P?
Sorry,
130. Yep. So 130. For L, okay, that was my single variable. That's going to stay the same. And Alex, what about for W?
You just put in 1/4.
1/4 L. Just make sure we keep that 2 before it. Great. Is there anything here I should simplify before I'm going to be combining like terms, but it's something I got to simplify first. See some arithmetic we can do, Corey? Kevin?
2 times 1/4.
Yeah, let's do out that 2 times 1/4. Let's keep this the same. Do you know what that is, Kevin? 2 times 1/4? If you multiply straight across.
2/4.
Yeah, good, 2/4. And if you want, you can reduce 2/4 to what number? 1/2. Good. Okay, so now we have 130 equals 2L plus 1/2 L. Now I've got my like terms. Okay, Logan, what do you get when you combine like terms here?
You get 2.5.
Sure, you can do it as a decimal. 2.5 L. And now my last step, and then I'll have L by itself. Okay, Zach, what's my last step?
Divide.
Yep, divide by
No,
2.5. 2.5. Right, so we use our calculator. Take 130, divide by 2.5, and I get a length of 52 what? Inches. Yep, inches. Okay, am I done? What do you think? Are we all done? No? What do we still have to find besides the length? Gage, what do we still have to find?
We found the length, what else do we have to find?
The width.
Find the width. All right, so I'm going to go back up. And right here, I'm going to put this equals 52. And now, how do I get my width? What do we do? Now that we know the length, we can get the width. Court, go ahead. What were you saying? Yeah, 1/4 times the length. Okay, now we know the length. Length is 52. Okay, so 1/4 of 52. Does anybody know what that is? Not sure? If you're not sure, you can just multiply it out. Okay, it comes out to 13. 13 inches. Hey, are we done now? Yeah, now we're done. Okay, any questions on any of our steps there? All right, let's see what we have here. Do you guys want to try one more of the rectangle problems, try to get good at that. What do you think?
Stick, you wanna see if they could set it up?
Do you guys think you need to do one more?
You guys wanna try one on your own? See, we only have one example left after this.
Let's go to the triangle one first.
Okay.
All right? Just because I think that one might take a little bit longer. And then if we have time, we'll come back and have you
Yes, we're gonna
guys.
skip example 3, guys, and we'll come back at the end, and you guys work on that one on your own.
All right, so this one, a little different. Okay, it says the first side of a triangle is 3 centimeters longer than the second. Okay, for now, I'm just going to look at that first sentence. Okay, forget about everything else. First side is 3 centimeters longer than twice the second. Okay, so I just started by writing my 3 sides. First side, second side, third side.
So instead, like a rectangle problem, guys, we had 2 things. We had length and width. But now for a rectangle, for a triangle, we're gonna have 3 things, because it's 3 sides.
Okay, now reading that first sentence, the first side is 3 centimeters longer than the second. Which thing there do you think is going to get the single variable? First side or second side? Which one?
First one,
Okay, how come?
because it's 3 times second side.
Where's the key location you look that tells you which one gets the single variable? Where do you look? At the end. Okay, you always look at the end of the sentence, and that's the one that gets the single variable. So in this case, Rose, which one gets the single variable? Second side. Yeah. Okay, I think what I'm going to use here, let's just use X. I'm going to stay away from S for side because that could look like a 5. So that's X. Now it says the first side is 3 longer than the second. So how would I do that? The first side,
3 longer than
the second.
second.
So you do 3 plus x.
Yeah, I'm just going to add 3.
If you put x plus 3, you're not wrong. All right, when you're doing something, you're using something that translates to addition, doesn't matter the order. Only for subtraction, the order matters. You do x plus 3 or 3 plus x, doesn't matter.
Right. Sam, is there any additional information I can get from that first sentence? No, we've gotten everything we can out of it. Now we're going to move on to the second sentence. The third side is 4 shorter than twice the second. Okay? The third side is 4 centimeters shorter than twice the second. All right? So let's start with that 4 shorter. What does that mean we're going to do? Yeah?
Subtract 2x.
Does it say it's 2x shorter or 4 shorter?
Oh, no, like.
4 shorter. Yeah? Yeah, so that's perfect. I'm going to start with the -4. Okay, you always put that in the second part. And now the first part, Caitlin already said, twice the second. Okay, well, the second side is x. We want twice the second, so it's 2x. So there's our 3 sides. All right, if we're going to solve a problem about perimeter, we got to use the formula for the perimeter of a rectangle. Okay, this is the first time we've used it. So if you have to look back at your notes, go ahead. But can somebody remind me what's the formula for perimeter of a triangle? If I said rectangle, I meant triangle. Yep. So first side plus second side plus third side. All right, now Ryan, what am I going to do with these 3 things and the number for perimeter? What am I going to do with the 3 plus x, the x, and the 2x minus 4? Yeah, we're going to plug them in. Exactly. We're going to put them in that formula. Okay? We have to fill in all 4 of these things. All right. Alex, what's my perimeter?
31 centimeters.
Perimeter is 31. Okay, Maria, what's my first side?
3 plus x.
3 plus x. Ben, what's my second side?
X.
X. And Callan, what's my third side? 2x minus 4. All right, so now we're just going to solve for x. And once I solve for that, that will tell me my second side. Right? All right, so we get 31 equals, anyone think they can tell me what I get when I combine all my x's on the right? How many x's when I combine all those together? 4. 1x, a 1x, and a 2x. 1 plus 1 plus 2. So we get 4x, taking care of that. And what about 3 take away 4? Logan? Michaela, can you help him out? Not sure. Kevin? Yeah. We just combined all our like terms together. So we had an x, and a 2x, and then we have a 3 minus 4. Okay. How about Gabe? What's my next step to solve this equation? Good. We're going to add 1 to both sides. So that cancels out. We get 32 equals 4x. And what is my last step? Ryan?
Divide by 4.
Good. Divide by 4. Divide by 4. And what's 32 divided by 4? 8. Okay, what were my units in this problem? Centimeters. Hey, so x is 8 centimeters. So Ariana, now that I know x is 8 centimeters, what side do I know? Yeah, I know the second side is 8 centimeters. Now, Victor, since x is 8, how do I get the first side?
But you said x is 8,
Yeah, we got x is 8.
so it's going to be 8 plus 3, right?
Yeah, we're going to do 3. Fill in 8 for x. So how long is the first side?
11.
11 centimeters. And the third side, about Corey? How do I get the third side?
2 times 8, 6 times 4 is 12.
Why'd you do 2 times 8?
Because
Why'd you do 2 times 8 here?
there's no I can't answer this right now.
Anybody help him out? Why is he doing 2 times 8? Why not 2 times 5? Yeah.
Because the variable's next to it and you already plugged in x.
Okay, but why 8?
There's no addition.
Yeah. X is 8. That's why. Okay, we solved for x. X is 8. So change x to 8. That's why you're doing 2 times 8. So 16 minus 4, which gives me 12 centimeters. Okay, any questions on that? All right, so what I'm going to do, I'm just going to put up the last thing for you guys. After that, I'm going to let you guys go back and try example 3. Okay, so tonight you'll have a homework with a little bit of review from the midterm and some stuff from this section. Tomorrow is going to be a review day. The stuff from today is going to be on the midterm and it's on the test. Okay, last test of the quarter is tomorrow. There's going to be a little bit of review homework to put you guys ready for the midterm over shop week.
10 problems.
10 problems.
Wait, how many
On the mid,
questions are gonna be on the midterm?
the midterm, I think, is about 25 to 30. It's about 30. And don't forget, your midterm exam is next academic Thursday, which is the 28th.
Can't believe you're giving a shot.
All right. Okay, any questions on that?
You guys, don't put those notes away, because you're gonna do that last, you're gonna do example number 3 right now.
Yep, so now I'll let you guys work on the example 3.